Hello everyone, welcome to lesson 50 of my PySimpleGUI lessons. In today's video, we're going to be doing an overview on matplotlib and data visualization. So first, we need to install the library called matplotlib. So I'm going to write step-by-step instructions on how to install. So how to install matplotlib. So step number 1, we press Windows plus R. Then step number 2, we type in cmd in the command. Number 3, in the DOI system, we type in pip install matplotlib. And then lastly, we press return. So now there's going to be a video showcasing that. Alright, now that we finished installing matplotlib, let's test it out to see if this is working. In between every single different variation of the code, I'm going to be using this as a separator. Okay, so we can import matplotlib and we can print the version. So 2 underscore version 2 underscore. Sorry, I spelled this wrong. Alright, so now let's run this. And as you can see, my version is 3.5.3. So now let's get onto the actual code. So again, the separator. Now the first thing we do is import matplotlib, and then we only need one aspect of it called pyplot. This is making the plots, graphs, and everything. And we can import this as plt. This way it's easier to write. And we also need this other library called numpy. We can import this as np. NumPy is built into Python, so you don't need to install this separately. Alright, so for the first graph, let's make a simple line graph. We need to write all the x points down in an array using NumPy. You don't need to understand how the array works. So we just write some numbers, 1, 2, let's say 6 and 8, and then some y points. Don't forget the square brackets, 3, 8, 1, and 10. So now there should be some points 1, 3, 2, 8, 6, 1, and 8, 10. Alright, now we can plot this. plt, which is the library, .plot. Plot, and then inside we write x, y. X points, y points. Alright, and then one last really crucial step, you need to show this whole plot. If we don't show it, we are unable to see this. So now when we run this, we have this simple line graph. So we start at 1, 3, we go to 2, 8, then drop down to 6, 1, and lastly go to 8, 10. So this is a really simple line graph. And now let's show you how to make this a little simpler. So again, with the separator, let's import all of this back in again. NumPy. And then now, instead of writing the x, let's just only write the y. Let's keep this the same, 3, 8, 3, 8, 1, 10. Let's add a few more, 5 and 7. Now, let's make the plot, y points. Now, we don't need the x points in here. Let's just show this. Okay, so now we have this really interesting array. So now if we look at each point, 3, 8, 1, 10, 5, and 7, the x corresponds to numbers 0, 1, 2, 3, 4, 5. I'm sure you can figure out the pattern. It starts at 0 and adds 1 every single time for every array inside this. Oh, for every single value inside the array. So that's the default if x isn't defined. Alright, now let's make a new version. In this version, we're going to talk about some of the different attributes. So let's import y points, array, same as last time, 3, 8, 1, 10, 5, and 7. Then we can plot this again like usual, and y points, and then show the plot to make sure this is working. Alright, so now it's working. So the attributes are, there are quite a few. So first, let's do something with a string. Inside this string, we have 3 different values. We have a marker, a line style, and a color. Now, let's show them one at a time. So first, we have the marker. Let's say it's this one character to represent what the marker is. So let's use O, for example. This would be a circle. Like this, a circle. And of course, there are other types of shapes like small x, like this, a diamond, like this, or you can even write a bigger diamond, like this, a bigger diamond, or you can make a hexagon. Now these are just some of the popular ones. There are a lot more. So this is the first one, the marker. Next we have the line style. Line style is quite interesting. First, we have a hyphen by itself. This is just a sturdy black line like this. And let's change it up. We can do a dotted line. Now we have a simple dotted line like this. We can make this dotted line a bit longer. We can use 2 hyphens. And now the dots are like small line segments now, like this. And we can do line segments and dotted lines like this, a hyphen and a period. Now it would be like this, hyphen, period, like this, all along. And that is line style. It's either 1 character or 2 characters. And lastly, for the third character, we have the color. So colors, there are, let's say, red. There's the whole RGB. Red, everything would be red. We have the green, and we have blue. RGB, of course, most classic 3 colors. RGB, alright, blue. Next we have, let's say white and black. White is W. Since it's white, we can't see it. And next we have black. So according to all the other ones, black, the first letter is B. So we should write B. But if we write B, this is the same letter as blue. So it would only show up as blue. Now, matplotlib uses another letter called K, black. In the K, alright, so K is black. Alright, so these are the 3 different values we can use in this string. Of course, you can make them separate. You can put them into marker, is this, and you can give this line style. Line style is this one, and we can give color to this. Color is this one. Don't forget the commas. Alright, now it would be the exact same. You can abbreviate color into C. Alright, after the marker, line style, and color, we have something called the marker size. So marker is this, we can change the size. Let's change this. Marker size can be abbreviated into MS. Marker size is, let's say, 20. Now, the size becomes a little bigger. We can make this even bigger, let's say 200. It would be like this. That's way too big. So let's change this into, we can also change this smaller, say 10. Alright, something like this. And then after marker size, we have two different other values about the marker. First, we have the marker edge color. Marker edge color, so MEC, that's its abbreviation. And this is a color, let's say red. And now the edge of the marker over here, it would be red, like this. And along with marker edge color, we have the marker edge, the marker face color, MFC, marker face color. So for this, let's say blue, not black, this is blue. The inside, which is known as the face, is blue. We can change this to something else, let's say G. It would be something like this, green and a red border, also known as the edge. Alright, after this, we have one about the line style. It's called the line width. This changes the width of the line. Let's say, change it to 12. This would be a bit thicker. Alright, so those are some attributes about plt.plot. Next, let's showcase how to put two different graphs on the same plot. So again, we import matplotlib.pyplot as plt, and we can import numpy as np. Then let's just do the default x, so we don't use it. Y1, since we need two y's. Y1 can be, let's say, 3, 8, 1, and 10. And Y2 can be, let's say, 6, 2, 7, and 11. So now, oh wait, sorry, I forgot to do the plot. So we can plot the Y1, and we can, again, plot Y2. Now, these should be in the same plot. So if we run this, there are two different functions. For Y1, it would be 3, 8, 1, and 10. And then for Y2, the orange one, it would be 6, 2, 7, and 11. 7 is not quite obvious, but it does change a little bit. And of course, we can add x onto this. We can say x1 equals np.array. Oh wait, I forgot to add the array, sorry. Alright, so for x1, let's just keep it the same, 1, 2, 3. And for x2, let's just do the same thing. 0, 1, 2, 3. Oh, 0, 1, 2, sorry. 0, 1, 2, 3. Now it should remain the same. Yeah, so this remains the same. So that's how you put two functions on the same plot. Next, let's showcase how we label the different plots, or the different parts of the graph, if you will. So let's import matplotlib.pyplot as plt. Then we import numpy as np. Let's make a really simple one. So let's do just two values. So this could be just a straight line. 617. So let's do 4 and 9. So now we can plot this one, and we can show this to make sure it's working. Alright, so now we have this simple line right here with the plot and show. Alright, after this, we can label them. So we can label the x-axis, y-axis, and the title separately. So we can label the x-axis using x label. Let's say x-axis, and then label the y-axis with y-axis. And then we can label the title with title. Let's just call this graph title. And now let's run this. Okay, so as you can tell, we can have the y-axis, x-axis, and the graph title right here. Okay, so for these we have one attribute. It's called the font dictionary. So font dictionary, it can change the font, and as the name suggests, it's a dictionary. So we can do font, and using a dictionary type, we can have 3 different keys. Let's say family. Inside family, we have a few different choices. We have serif, sans serif, monospace, cursive, and fantasy. So now let's just keep it as fantasy, and we can select the color of this font. Let's say green. And lastly, we have the size, which would just be the size of the font. Let's say 15, and we put font here. Let's put this the same thing in this. Again, for title, font dictionary equals font. Alright, let's run this. So now, as you can tell, the different axis and the title is now green, and the size is a little bigger. Alright, after this, let's change the fantasy into, let's say, cursive. And now this changes. It turns into this different type of font. Okay, so this is how to label. Alright, after labeling, we have the grid. So the grid is pretty simple. Let's use the same thing, just the straight line, 617, 4 and 9, and then we can plot this and show. Alright, so now, oh wait, sorry, in the plot we need to write x and y. Now it would be like this, a straight line. And so now, in order to add a grid, under here we can use this called grid, and now there would be this grid like this, and we can specify what type of grid we want. Let's say the axis, let's say only y. Now it would be y-axis only, like this. If we want x, it would be like this, x-axis. And if we want both of them, let's write both. the axis is really useful to see clearly and easily what the value is. After axis, we can change the color. Let's say change this to green. And now it would be green. We can also change the line style into, let's say, dotted lines, or like longer dotted lines like this. We can change it to small dotted lines with a colon. It would be like this. And mixed, we can use colon period. Oh yeah, by the way, period colon doesn't work here. It has to be colon period. And after line style, we have the line width. This changes the width of the lines. Let's say 1.5. This is a pretty good width. So like this. We can also make it really big. Let's say 3. So now it would look like this. Okay, let's change this back to 1.5. Alright. So this is grid. After grid, we have... Okay, this one is quite complicated. We put different plots inside the same window. Okay, so for the first plot, let's just keep this the same. 6, 17, and y. We would do 4 and 9. So let's put this into a subplot. Subplots are used to put different plots inside the same window. So plots need 3 values. The first one is the row number, let's say 1, and second is column number. Think of it as a rectangle. It's 1, the height is 1 and the width is 2. So now there should be 2 different plots available. And this is plot number 1. The third value is the plot this number is. The plot number. Alright, and we can plot this x and y. And then let's put another subplot. This subplot, you need to follow this same width and height, 1 and 2. And lastly, this is not plot number 1 anymore. This is plot number 2, which is the one on the right, because we have 2 plots on the columns, 2 columns of plots, and each plot only has 1 row. Alright, and let's define another x and y. This one, let's put one more value into it. 3, 6, 9. And 9, 12, 3. Now let's plot this. Oh, sorry. Plot x and y. Alright, so now let's run this. Okay. Also, really important, don't forget to write down show. Alright, so now we have these 2 different plots. This plot number 1 and plot number 2. Of course, we can label this with plt.title. This one, let's say plot 1. And here we can say plot 2. So now it would be like this. So now we have 2 columns, each column with 2 rows. How about if we move this plot number 2 over here? So it would be 2 rows but 1 column. So in order to do that, we change row number into 2 and only 1 column. Don't forget for the second one to change this as well. Okay, so now it would be like this, plot 1, plot 2. By the way, if both the row and column is bigger than 1, the numbering system goes from left to right and then from up to down. So the same way as we normally read. That way it's simpler to code. Alright, so this is putting multiple plots in the same window. After this one, we have the... Alright, now we finished everything with the different plots, the line graphs. Next, let's move on to scatter. Everything we talked about here, like the different subplots and the grid, this all works with all the other graphs. So let's import matplotlib.pyplot as plt, import numpy as np, and then for the scatter plot, it doesn't really matter what the array is. Let's just put random numbers. Alright, and give this a y. So it's really important that the x and y has to have the same amount of values. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, 4, 5, 6, 7, 8. So both of these have 8. And now we can put this in a scatter plot. So before we used to write plot like this. Now instead of writing plot, because plot is line graph, we write scatter for scatter plot. And we use x and y. Now let's run this. Oh, again, don't forget to write the show. Now we have the different scatter. Alright, so for these scatter plots, we have a few different attributes we can change. So first we have the colors. Let's give this called my colors and give this their own array. Let's say different colors. What can I choose? Black, white, RGB, red, green, blue, and let's pick some other ones. Let's say cyan, and how about yellow? So now we have the different colors, and we can give this colors equals my colors, and let's make sure we have the same amount of values as this. 1, 2, 3, 4, 5, 6, 7. Oh, so we're short one. Let's add something else. Let's say like pink. Okay, so now let's run this. Oh, I'm sorry, colors can only be one, or there's no color. It has to be color, not colors. So we use C for colors. And now we have the different colors here. So this is the colors. And after colors, we have the size. Size is S. So for size, we can do my size, np.array. So for size, we can do like a bunch of random numbers. 1000, 2534, 5612, 6666, 2315, 5931, 1, 2, 3, 4, 5, 6, 2 more, 4321, and 1, 2, 3, 4. So now we assign this to S, which is size, my size. And now, as you can tell, we have a wide variety of different sizes. And last attribute we can change is the visibility or transparency, if you will. This one is called alpha. Alpha. And for alpha, it's a float number from 0 to 1. So let's say 0.5, this would be half visible, and it would be like this. If we want it less visible, let's say 0.2. it would be like this. 1 is completely visible, no transparency. Alright, so this is scatter plot. After scatter plot, we have the bar graph. So for bar graph, the x-axis we don't label with numbers. We label the x-axis as letters. Let's say A. It doesn't have to be letters. It can be like other things as well, whatever your graph is about. But Y, you normally put numbers here. So for Y, oh yeah, don't forget the array. And for this one as well. So for arrays, this one, let's put some random numbers, 3, 8, 1, and let's say 10. Okay, and then we put this in a bar graph, BAR for bar, and then X and Y with the show. Don't forget show. And now, let's run this. We have this bar graph, A, B, C, and D at 3, 8, 1, 10. Okay, so this, we can change a few attributes as well. We can change the color, let's say brown. And now the color is this brownish color. Another attribute we can change is the width. The width is the bar width. Let's say 0.1. This is another float between 0 and 1. 0.1 would be really skinny, and if we want it the widest as possible, we do 1. This would be touching, like as wide as possible. There would be no space in between. Alright, so this is the bar graph. Another variation of this same bar graph is the horizontal bar graph. We use bar, but we put H at the end for horizontal. And we can do the same X and Y. Now it would be like this. Now instead of width, the bar graph for horizontally, it would be called height. It has the exact same effect and the same values. If we put 1, it would be really wide, and we can make this smaller as well, 0.1. The height would be really small. So this is the horizontal bar. After the horizontal bar, we have the last graph here. It's the pie chart. So let's import matplotlib.pyplot as plt, and we can import numpy as np, numpy. Alright. And now we don't need the x-axis for this. We only need y, and y is not really y anymore. It's just the percentages of the pie. So make sure the values added together is equal to 100. Let's do 35, 25, 25, and 15. So 35 plus 25 is 60, plus 25 plus 15, that would be 100. And now let's put this in a pie, like this, plt.py, and we put y here. So now let's run this. Oh, don't forget show. And now there would be this pie graph. This one is 35, this one is 25, this one is 25, and this one is 15%. So this is the pie graph, and we can add a bunch of different attributes. We can make labels, and let's say my labels. Let's label this different fruits, apples, bananas, cherries, and dates. Don't forget the string around this, and don't forget the array. Alright, now we can put my labels here, and we would get the desired labels: apples, bananas, cherries, and dates. Alright, so now that is the labels. After labels, we have the star angle. So star angle is a degrees from 0 to 360. So at the start, when we have 0, oh sorry, it's start angle, not star angle. Forgot the T here. And now this would start at 0 degrees. To the right, it would be 0, and we're using degrees, so towards the north or up, it would be 90. Towards the left, it would be 180, and 270 is downwards. So let's see, in between apples and dates is the start. If we change this to 90 degrees, 90, it would start here. If we change this to 180, this would start over here, and 270 here, I hope. 270 would be downwards, and 0 would be again back to the right. Alright, so this is star angle. After start angle, we have the explode. Now explode isn't as dramatic as it sounds. It's basically, let's just give this a value. Let's say 0.2 for the apples. We explode that a little, and everything else is 0. Now we put my explode here. Now we can see apples gets reached out a little bit, so that is what this calls as explode. And we can change the explode value here. Let's say 0.5, and it would be out more. Let's keep this at 0.2. And alright, after explode, we have something called the shadow. So shadow, unlike everything else, is a boolean. So either true or false. If this is true, then we get this nice looking shadow here. This shadow right here. Alright, so after shadow, we have the colors. Let's give this my colors. Let's say brown, red, orange, and yellow. So now let's put my colors here. And now, so apples is brown, bananas are red, cherries are orange, and dates are yellow. Alright, so those are colors. And lastly, we can make a legend for these different labels and their colors. So we can do a legend like this, and it would show up here. So this, apples are brown, bananas red, cherries are orange, and dates are yellow. We can give this one a title by using the title attribute. Let's say legend title, and it would show up here. Let's move this to, like, let's say the upper left corner to not block the apples here, the label apples behind this. So we can use another attribute called location, LOC. This is upper left, let's say. And now this would move here. So now it would be here. Alright, that concludes lesson 50 of my PySimpleGUI course. As of right now, all 50 lessons about graphical user interface designing and data visualization are finished. I hope you learned a lot in this series of lessons and will continue to improve your skills. Thank you for watching, and see you in the future courses. And remember, crack the coding enigma with work for tuition as your sigma.